It is recording right now. All right. Well, it is 9 o'clock. I am getting the lecture started. What you're seeing on the screen is the distribution of the grade. I will send you a scanned copy of your own exam and also the scoring of the exam. So what we can see here is on the left-hand side, we have a histogram of the frequencies of each grade. So we can see that there are 9 people getting A's, there are 11 people getting B's, 4 people getting C's, 4 people getting D's, and 1 person getting an F. And those are only accounting for people who showed up for the exam. There might be a few people who did not show up at all, so those are not even counted in the histogram. The other one is a little bit more interesting. It gives you more information. This is basically sorting, after I sort the scores of the entire class, I just kind of plot out, all the scores. So when you see a flat line, that means there are a few people getting the same grade. When you see a curve that is really relatively flat, that means these people, in terms of their performing in this class, are really close together. And whenever you see a, kind of like a dip like this, that means for whatever reason, okay, there's a gap between the group over here and the gap that is, I mean, the group that is over here. So that's kind of, how we can interpret the plot. So for this particular exam, 3 people got perfect scores, like 4 out of 4. So that's how we ended up with, like 1, 2, and 3 people all the way to the end here. They're all getting fours, but I did promise that I would adjust the highest score based on the 90th percentile. So if I use actually just the 90th percentile, there would have been no adjustment because, the top score, the top 3 scores of the entire class, they are all 4.0 out of 4.0. But I decided, okay, I'm just gonna interpolate a little bit, with the fourth highest score versus the top score, and then just kind of pick a midpoint in between and go like, okay, we'll make that a new, 100%. So there's a little bit of adjustment, but not a whole lot, because of the distribution of the curve. Do we have any questions about these two graphs? One is a frequency histogram, and then the other one is an actual plot. So you will be receiving your own score, maybe within the day, okay? Because I have to kind of run the script to do that. So you'll be getting your own score, and this picture can basically help you identify where you are in the class. Okay, so if you, let's just say somebody has a 3.5 out of 4, so that person would be about here. So in terms of percentile in this class, that would be about 60-ish, percentile, 60 to 70 percentile. Okay, so I'm not emphasizing that the percentile is super duper important, okay? But it is kind of nice to know, because anywhere from here all the way to the top, I think these people will be fine, okay? They would be just fine. And then somewhere from here to here is like, well, those people are doing really great too, okay? I'm not going to be too concerned about those people. But people who are kind of, from here all the way down here, I think those people may need to review how they get ready for exams and how they study. So this is just a feedback information for people to maybe look into possibilities of studying in a different way. So are we good so far with all this? We good? All right, excellent. Um, so when you get your score, one more thing you can also do is to compare the score that you're getting with what you thought you would be getting. Okay, because that's also kind of important. Okay, so and I'm usually, well, not usually, I am always available, right before class because that's the office hour. So from 8 to 9, right before this class is my office hour. If you have any concerns, if you need to ask me any questions, or if you think I did not score something correctly, you can always come to my office and we can talk about that. We, is that okay? All right, excellent. So what we'll do next is we're going to go back and talk about the homework assignment that was due today. So the homework assignment that was due today, yes, I have a lot of homework to grade, but I have to keep going. Okay, so this is the homework that was due today, and this is one particular person's submission, which we cannot see anyway. That's okay. All right, so this is the homework that was due today. This is a relatively simple um, example of how to use a function. So we're going to take a look at this one first. And also, there's a recording on Monday. That's also really important to have watched that video before class today. Do we have any general questions about the homework assignment? No questions? All right. So we're gonna, take a look at this and work it out, and then we'll talk about the new homework assignment. So this is just what I usually do. Okay, you open it up, take a snapshot, put it at the corner, and then we work on the actual trace. All right, so we just stick it up here, and then we are going to use a new sheet in the shared folder. So if you have a computer, if you have a laptop, or even on the cell phone, you can follow along if you want to. It is now called 2025-1022. Yep. Okay. All right. So we're going to take a look at this particular program. We always have comments, and then we have, oops, line number. There's nothing to say about the precondition. And then we start execution on line 5. Technically, line 5 doesn't do a single thing, but it's okay. We can keep that. And then we move on to line 6. So line 6 is the definition of a local variable. In this case, it's called x. So that means we have to allocate a new column called x, and then we give it an initial value of unknown. And then we continue to line 7. So line 7 is a little bit interesting because it's the beginning of a conditional statement. But in order to determine whether the condition is true or false, we have to perform two function calls first. We cannot do both of the function calls at the same time. We can only make one call at a time. Now, in this particular case, if you want to say, I don't like to follow rules, I don't want to go from left to right, I want to go from right to left, that's fine, actually, okay? Because in an addition, going from right to left versus, going from left to right does not really make a difference, so it can go either way. But I am going to stick with, left to right. So that means on line 7, I have to first take care of the left invocation of 1 it's left to the addition operator. So that's the one that I need to take care of now. So that means I have to call function 1. And to do that, I have to allocate a new column called return info because we are not returning to the next line. We have to return back to line 7. And that's the differentiation between using a return line number, which is always going to a different line, versus return info, which means we're going back to the same line because there are some additional operations on that line that I have to finish. So in this case, we're basically just copying the entire line 7, except for the call that we are handling right now. That one is replaced by a single question mark, and then the rest we are just going to copy like so. Okay, so it is really just literally a copy of the original line 7, except the call that we are taking care of is now replaced by a single question mark, which is a placeholder. It is the placeholder of the return value of 1. There we go. And we don't have any parameters. So in this case, we don't have any parameters. So this is all we need to remember. After this, we can now continue execution at the definition of 1, which starts on line 1. It doesn't do a single thing. And then we get to line 2. So on line 2, we are executing a return statement with a value of 1. So 1 here is the return value of the return statement. So when we execute a return statement, we need to look up the rightmost return info column, which in this case is column D. So we copy the actual content of that column, not the heading, but the content of that column. And then we change the question mark to the value that we are returning. The value that we're returning is whatever is on the right-hand side of the word return. And in this case, it's a really simple constant, which is just 1. So we are replacing the question mark with the value of 1, and that's it. Okay, this is all we need to do for that particular cell. But the return statement has some additional stuff that it needs to do. So the other thing we also need to do is to copy this entire cell over here. We skip one row and it'll be clear why we skip that one row. So we have to copy this entire thing over here. So instead of copying, I can use the equal symbol. Basically, it is doing the same thing as copying, but it is a lot, it saves a lot of time. Okay. And then the next thing we need to do is to say, okay, we are now concluding the execution of the function call of 1, which means I'm now ready to go back. So once we are ready to go back and we have copied this cell over here, this column, column D, is no longer useful to me anymore. So I'm going to deallocate it. So to deallocate is really just copying and pasting the heading of the column and then use Alt Shift 5 to strike it through to indicate that column is no longer in use. So now the execution is going back to line 7, and this is what line 7 looks like now. Can we do the comparison at this point? Yes, go ahead. Not super duper important, but I try my best to reflect exactly what else we need to do on that line. So if you don't put a open brace, it's okay. I'm not going to take points off. Yep. But the rest is important. The word if is important, and then the rest of the expression is important. Yeah. The open brace, not so much. We get the idea of what we need to do. hmm All right. So getting back to the question, are we ready to evaluate the equal at this point? We are not yet. Okay, not yet ready because we still have another call to 1. All right, so we have to do pretty much the same thing. Allocate the leftmost available column, which is once again column D, because column D was used before, but it was also deallocated before this point of time. So we are reallocating column D, so we have to kind of put that heading back into it. And then we now have to say, okay, when we get back to line 7, what else do we have to do? Well, the first one is already resolved, so we just copy that one over here. The second one, or the second call to the function 1, is now replaced by a single question mark because that is the invocation that we are taking care of at this point. And then the rest of the line is really just copy and pasting from this particular cell over here. So this is how we set up the return info in the second call, or when we perform the invocation of 1 on the right hand side of the addition. So now we get to the beginning of the definition of one as a function. Starts on line 1, get to line 2. So when we get to line 2, we are doing the same thing that we did before. We look up the rightmost return info cell, and that would be column D. Copy and paste the value of that particular cell, and then we change the question mark to the value that we are returning, which is also just 1 in this case. So we don't Okay, so at this point, we do not combine and say, oh, I know what is 1 plus 1, it is 2. We do not do a single thing about the addition. Okay, the only job of the return statement is to replace the question mark with a particular value. That is all it does. Okay, and then we have to copy and paste this over here. So I would just do the usual lazy thing, okay, copy and paste it. And then we have to now indicate that column D is no longer in use. You'll put the return info over here. And now we're getting back to line 7 again. But this time, I think we know enough to evaluate the equal, which is checking for equality. 1 plus 1 is a 2. The other side is just 2. So now we can now say, 1 plus 1 equals 2 is true. So now we can determine which way to go. We have a then statement over here on line 8. So that's where we're going to go. So we go to line 8. But when we get to line 8, guess what? 1 is also on the right-hand side of the assignment. So that means we have to call 1 again. So that means we are going to have to reallocate the leftmost available column, which is column D, and label as return info. But this time we are returning back to line 8, and the unfinished business on line 8 is going to be 1 equals to the question mark. And once again, the question mark is the placeholder of the invocation of ONE as a function on line 8. So once we have that set up, we go back to line 1 again, which doesn't do a single thing. We go to line 2, and then we just kind of do exactly the same thing as last time. Copy, paste, replace the question mark with the value that we are returning. Copy and paste this onto this cell, like so. And then we mark the column as not used anymore. Okay, we deallocate the column, like so. And now we're getting back to line 8. Once we get back to line 8, it is an assignment operation, and we want to find out where x is. So this has to do with local variables. I think we talked about local variables on Monday for sure. Um, so the way we look it up is we look up the rightmost column that is labeled x in this case, and that is column C. So now column C is updated to a value of 1, and then we get to line 9, and nope, I take it back. We do not get to line 9. We go straight to line 10 because there because this is a then statement. And once we execute the then statement, we get to the end of the entire conditional statement, and then we get to line 10. And line 10 is basically marking the end of the execution of the entire program. So at this point, we conclude the execution and we are done. All right. So do we have any questions about this particular trace? Hmm? On line 10, it is a return 0, but because it's from main, what we have talked about in this class is when we return 0 from main, we just go like, okay, this is the end of the execution of the whole program. All right, so do we have any other questions about this trace? Any conceptual question? Any question about, the notations that I use? Yep, go ahead. For row row 17, uh-huh. So um, we line 8, we need to visit line 8 twice. Once it's here, and then once it's over here. Because the first time we get to line 8 looks like this, which means we really do not know what is the value on the right-hand side until we perform the function call to ONE. And that's why we have to go through all of this process here to invoke, the function called ONE1. And only after it is done, only after the return statement of line 2, that we know that, oh, that question mark over here, which is replacing the function call itself, is is a placeholder of the value of 1. So only at that time we know that the right-hand side of the assignment is 1, and then only after we return from 1 that we know what to put into variable x. Mhm. So the mechanism is essentially the same as what we did on line 7, except instead of using the return value to perform the addition, which then is used for the comparison, we're only using the return value right away to specify how we should change x. But the concept is still the same. Yep. Yeah, go ahead. hmm So in this particular program, obviously it is a useless program, right? Um, but the whole purpose of this program is for you to practice. how we denote the tracing of a program like this. So it is more about the mechanism itself than the actual meaning of how we use the mechanism in the context of the algorithm itself. So we are really just looking into the mechanism of returning a value from a function, as opposed to, this program actually does anything particularly useful. Yep. Any other questions? No questions? Because I don't want to kind of load up this class with something that is kind of really involved to begin with. Um, and the more involved the version of something like this is the lecture on Monday, because on Monday I talked about the Fibonacci recursive Fibonacci algorithm. So in that case, it does return a value that is useful because it is used to compute the Fibonacci sequence. All right. All right. So any other questions? Those are all really good questions. Any other concerns, questions? We all good? All right. All right. So I'm just double checking, making sure the recording is good because yesterday I recorded about 60% of a lecture and then to find out that I did not turn on the mic. That happens to me. So I have to kind of remind myself to check occasionally. All right, cool. So now you have the solution to this particular homework assignment. So the first thing I would do, okay, is to compare my own answer to, in this homework assignment with the key, and then try to find out what the differences are. And then once I find the differences, I would go like, okay, why did I do it this way? And what is the meaning of text way of doing it, for this portion? And then make a note of that. Okay. So that would be the first thing that I do. I'm not going to wait for the professor to, kind of give me the feedback because, I can do it myself. I can actually compare my answer to the answer that the professor gave me, and I will do the comparison. Are we doing okay so far with that approach? Okay, cool. All right. So the next thing we're going to do is to take a look at your new homework assignment before we move on with some additional material. So your new homework assignment is not visible yet because I have not unhide it. So it is called recursion. It is due in a week. Okay. So let me unhide it right now, and now you can see it. So recursion one is basically another trace, okay? And this time the trace is stored in a Google Sheet, okay? So you can either, so what you can do, it's up to you, okay? So what you can do is to make a copy of this if you want to. So you can say make a copy, and then you just make a new sheet, for the trace itself. That's one way to do it. Or you can just, make a new sheet altogether, do your trace on the new sheets. That's up to you, okay? So this is the algorithm, okay, which is a little bit more involved, okay. We have a function f, in this case, it takes two parameters, and this time we have one single local variable in main, which is kind of the same thing that we did earlier, but the function f is having two return points. This is one, okay? This one is not too terrible, okay? I'm going to explain what is the percent symbol here. And then this one is a little bit more involved because it has two recursive calls within the return, okay? So for those of you who are thinking, we haven't seen anything like this, yes, we have on Monday. Okay, on Monday we talked about something almost exactly like this, except it only had one single parameter instead of two. But we actually watched something like this on Monday. Um, so the other thing that we need to do in this case is to describe what exactly is the percent symbol. What does it do? What does it mean? And also about the division. The slash here is a division. So now the question is, what if after the division I have something 0.5? Okay. So what if B is 1 and E is 2? 1 plus 2 is a 3. And then 3 divided by 2 is 1.5. So what do we do about the 1.5? Okay. So I will address both of those questions in the assignment description itself. Okay, but even though it's in there already, I will go ahead and just kind of give you a heads up. Okay, so the first one is the percent operator. It is an operator, just like multiplication, addition, and subtraction. the name of the operator is modulus, okay, but most people only call that as the mod operator, MOD. But the meaning of the operator is simply we want the remainder after a division, okay, as opposed to the quotient after a division. So the divide, which is the slash operator, is what we call the integer division, which means we only want to get the quotient after a division. So basically, one is getting the remainder after division, the other one is getting the quotient after the division. So every time you have a division, you have a dividend and also a divisor. So with both of these operators, the dividend is on the left-hand side of the operator, and then the divisor is on the right-hand side of the operator. So this is probably the most concise way that I can use to explain both of these operators, which means most people would get confused because it is too concise. So what we'll do is we're going to do some examples. So the example that I'm including in the assignment description itself, which means this is in the assignment, okay, is 13 divided by 5, okay? But remember, the slash means I only want to know what is the quotient, okay? So what is the quotient of 13 divided by 5? I mean, the answer is right there, right? It is 2, okay? So 2 is the quotient of that particular division, and then 13 mod 5, okay? The next one is asking what is the remainder of 13 divided by 5, and the answer to that question is 3. So are we all understanding how division works? Yes. Mm-hmm. It only gives you 3 as the answer. That is correct. All right. So for people who are still a little bit kind of cloudy of what these were, how they work, one way is to use a sample program to not sample program, but use the debugger to help you so they can experiment with these expressions. So you can just use whatever default program that comes with, I use online GDB. You can use some other tools. I think there's one called, I cannot remember. One student told me about that because online GDB was down on the day when Amazon or AWS went down, because apparently the back end of online GDB is also based on AWS. So it went down on that day too. But there was another resource. It works about the same way. I cannot remember the name of the website. It's onlinesomething.com, but I cannot remember. So if I remember, I'll tell you guys. But that's actually not super duper important unless AWS goes down again, okay? Which I don't think is going to happen for a while. Let's hope. So instead of doing that, I'm going to put a breakpoint on any line. Okay, even this line is fine. Okay, put a breakpoint on any line, and then you go into debug mode. So after you go into debug mode, you are now in the debugger. So the debugger actually understands most of the syntax of C++. So that's really helpful because now you can say, if you just want to go like, okay, what is 89 slash, okay, which is integer division, which gives you the quotient after division. So we're just gonna go like, okay, what about 14? Okay, the answer is 6. So 6 is the quotient of 89 divided by 14. So now you can say, what about mod? Okay, what is the remainder of 89 divided by 14? Then the remainder is a 5. So you can double check to make sure this is all correct, because now you can say, okay, if I multiply the quotient with the divisor and then add to it the remainder, I should get the dividend back. So, yep, we got 89 back. So are we good with those terminologies? Yes. There's no such thing as not having a remainder. What you meant is a remainder of 0. Yep. There's always a remainder. It's just a remainder of 0 in this case. So what you're talking about is, what about we are looking at 14 divided by 7? It's a 2. What about 14 mod 2? It is simply a 0. Yep, that is correct. Are we good so far with the terminology? So until this class, how many people actually remember without me prompting, what those terms mean? Dividend, divisor, quotient, and remainder. Okay, very good. Okay, excellent. Cool. So that's your homework, okay? That is your homework, for next week. We have everything already discussed, okay? Particularly the lecture on Monday is going to be particularly helpful because, what do we do when we have a return statement that has, two more things to return? And we are actually going to continue with that discussion today. Are we good? All right, cool. So let me see if I saved a copy because I might not have saved it before the computer crashed. So we'll take a look at my files over here and see if I have a copy of that program. Nope, that is not it. Okay, I do not have it here. So let me start up the editor and see if it saved a local copy. If not, we can always watch the video and get it back from the video itself. So we are going to, do you want to restore? Yes. Um, yep, this is it. This is one of them, and this is the other one. Okay, so I lied, okay, because on Monday I did not, did we get to this one on Monday? We did? Okay, so we're gonna do the more cryptic one today. So this is the one that we did on Monday. If this is like new to you, it's like I have never seen anything like this. Well, that means you might not have watched the video on Monday, which is my strong hint of you might want to watch it, right? Okay, so we're gonna go for the super cryptic one. So let me see where is this super cryptic one. I think it is right here. Okay, this is the super cryptic one. Um, and we're gonna go with this one. This is going to be the fun one to trace. All right, so this one introduces the ternary operator. So this is what we call a ternary operator. The ternary operator means three, okay? So that means there are three things in this operator when most operators are binary, which means they only handle two things. So this one has three components. A, B, and C are really just the placeholders of the three components. Syntactically speaking, A is on the left-hand side of the question mark, B is between the question mark and the colon, and then C is on the right-hand side of the colon. But each one can be a very complex expression if they need to be. So the meaning of the ternary expression is we first evaluate A. A is evaluated as a Boolean expression, which means it only gives you two possible answers, true or false. If A is true, then we evaluate B, and whatever B evaluates to becomes the value of the entire expression here. On the other hand, if A is false, then we proceed to evaluate C, and whatever the value of C is becomes the value of the entire expression like this. So that's kind of what we talked about on Monday as well. Okay, I also used the debugger to illustrate a few examples of that. So if you want to, I can quickly replicate some of the examples, but the point is you really need to watch that video. Okay, that's really kind of the point. All right, so we can now say, okay, what about 2 is greater than 3, question mark, 4 and 5. I think we had something like this on Monday. So when we evaluate this particular expression, 2 is greater than 3 takes the part of A, which means it is the condition to evaluate. It gives us either true or false. 2 is greater than 3 is false. So that means we have to go for the third item, evaluate it. It is 5. So that 5 becomes the value of the entire expression. So when I press the enter key, it simply sets 5. On the other hand, if I do something a little bit different, let me do something that involves the mod operator, right? So we'll go like, okay, what if we're looking at 6 mod 2 equal to 0? And then we say on one side, we say 42, and then on the other side, we say, mm, uh, another movie reference, okay? 666. There we go. All right. So what is it going to print? It's going to print 42 because 6 mod 2 is the remainder of 6 divided by 2, which is 0. 0 equals to 0 is true. So we evaluate the one in the middle, which is just 42. 42 becomes the value of the entire expression, the entire ternary expression. So it just returns 42 in this case. Are we doing okay so far with the ternary operator? Okay, yes. Oh, this question mark is nothing more than just a punctuation mark. Yep. They could have chosen a different punctuation mark, but the question mark is what they chose. So this question mark has nothing to do with the question mark that we use when we specify the return value. It really is just a marker to separate the first component from the second component. That's all it's doing. And then the colon, the only job of the colon is to separate the second component from the third component. So they're really just nothing more than markers so that we can differentiate who's the first, who's the second, and who's the third component. All right. So with that said, we are going back to the sample program that we were talking about here. So the first thing I'm going to do is really just to go over the program line by line, okay, just to make sure that we understand what each statement is saying without running the code. So we have main, which is the entry point of the entire program. We have a local variable x that belongs to main. And then on the next line, we are trying to call function f with a parameter with an argument of 3. And then whatever that return value turns out to be is what I would use to update local variable x. And then we are done from main's perspective. So the key is function f now. So function f has a single return statement. That's it. Okay. It has no conditional statement, nothing. It has a single return statement. But the single return statement has a fairly complex expression that specifies the value that it needs to return. It is a ternary expression. So this is the first part. It is considered to be an expression. This is the second part, which is the value that the entire expression should evaluate to if and only if the first part is true. If the first part is false, then it will return whatever value this expression turns out to be. But the interesting part is this particular expression is also recursive because it is calling f within f. Okay, so this program is actually runnable inside online GDB, but it won't tell you much about how it happens. Okay, because because online GDB and or any debugger does not have the ability to track down what is happening on the same line. Okay, so it will give you some feedback, but it's not going to be the same as the hand trace that we're going to do in this class. So I guess the mysterious part is the highlighted portion. So do we have any questions other than the highlighted portion right now, which is actually not super duper, mysterious because after all, that is also used in the program that we have already talked about on Monday, except this one is not inside a ternary expression, whereas the other one is inside a ternary expression. Are we doing okay so far? All right. Okay. So in this class, you are not required. I will not ask you to write your own algorithm because to write your own algorithm in this way is not easy. Okay, I get it. Okay, this is really not the kind of program that I can expect people from this class or even CISP 360 to write. But to trace it is a different story. Okay, to trace it means you just need to really understand the mechanism behind everything and be able to do it kind of really step by step procedurally so that you understand, okay, when we have this construct, it means it's going to do this in the computer. If I see this construct, it's going to do that inside the computer. That is what I really want to convey in this class is you need to understand the mechanism, not so much how to make up your own algorithm using the mechanisms. I just need you to understand how the mechanisms work. All right. So with that said, we are going to take a look at the execution of this program. And I need line numbers to do this. And I will only track this portion of the program. The earlier part are all kind of comments. They're not really needed for the tracing. So we'll go ahead and do just that. And it's okay not to start with line 1. There's no reason why we cannot start with line 7. So that part is okay. So we're going to take out all the unessential stuff and then go back to our spreadsheet for today. This is the one for today. And I start a new sheet to track down what is happening when we run this program. All right, same as usual, start with comments, and then we have line number. Line 11 is the beginning of the main function, doesn't really do a single thing. Line 12 is the definition of a local variable. So at that point, we allocate the leftmost available column and then name it x, which starts with an unknown value, like so. Okay. And then we continue on to the next line, which is on line 13. Line 13 is an assignment operation, but I cannot carry out the assignment operation yet because the right-hand side is a function call. I have to figure out what is the return value of that particular function call before I can finish the entire operation. So that's why we need a return info here, which reminds the computer when it is done with the first invocation of f, it has to return to line 13, and what is left on line 13 to do is really just the assignment operation. All right, but this time we also need one more column because f as a function has a parameter n. So the parameter n needs its own column, and in this case, the argument of 3 is said to be passed to parameter n. So that's why parameter n starts with a value of 3. So now we have set up all the columns in order for function f to do what it is supposed to do. Like so. So now we go to function f, start on line 7. Line 7 doesn't really do a single thing, so we get to line 8 right away. So when we get to line 8 the first time, this is exactly how line 8 looks like the first time, which means, okay, it is a ternary operation. We can do this part, okay? This part is easy. Whether n equals to 0 or n equals to 1, we know that, okay? So if you want to, you can document it on the side. N equals to 0 or n equals to 1 is false. Okay, but as a result of that, we have to evaluate the third part of the ternary expression. So that means we have to call function f over here. So this means um, when we document what is on line 8 as a return info, you have a choice here. I can give you guys a choice. You can say, okay, it's this or that, okay, plus that, sorry. So you can simplify the whole expression because we have already evaluated the first part of the ternary expression. We already know only the third part matters at this point. So if you want to, you can do this. Or if you want to be more complete, then we can actually write down the entire thing, okay? N equals to 0 or n equals to 1, question mark, n, colon, and we replace the first call with a question mark, but everything else stays exactly the same like this. Okay, so this is more complete, but if you want to simplify it, I can understand. All right. But because every time we call function f, we also need to provide a parameter. So now we need to figure out what n we're dealing with here. So this expression here, n minus 1, is trying to specify what goes into column G. So that means this n cannot be referring to the one that is in column G. It has to be referring to the rightmost n that already has a value. So which column is n that already has a value? Column E, very good. So column E has a value of 3, so that means 3 minus 1 is a 2. Okay, so now we put a 2 over here. So that finishes the allocation of all the columns for this particular function call. And then we continue execution. Guess what? On line 7 again. Okay, because it's calling f. So we always start at the beginning of the function that is being called. We do not just go like, but we were here already. Yeah, we were here, but we always start from the beginning. So we get to line 8 again. N equals to 0 or n equals to 1 is once again false because n is 2 this time, because this n over here, is now referring to the rightmost column that is labeled n. And at this time, the rightmost column that is labeled n is column G, which has a value of 2. So that means, okay, we cannot really do anything except to call function f again. Oh, cannot reuse the same column here. So I need a new column. Okay. Once again, return info is still going back to line 8. It's basically the same as last time. Okay. Or n equals 1, question mark, and colon, question mark plus f of n minus 2, semicolon. So it's kind of the same thing. And we also need another column for n. But when we set up column I, we are now looking at the rightmost column that already has a value of n. So that would be referring to column G. So that means this n minus 1, this n over here, is referring to column G, which has a value of 2. 2 minus 1 is a 1, so we put a 1 over here. Are there any questions about this chain? You good? All right. So assuming that we are good, okay, because I'm not a mind reader, I cannot really tell whether you guys have a question or not. So if you do have a question, you need to raise your hand and let me know that you have a question. Even if you don't know how to ask the question yet, you still need to let me know so that I can pause the lecture. Yes. Yeah, it is. Okay, so the reason why I did not expand the column is otherwise it gets really wide. Yep. Yep. So the other way I can do it, you guys can tell me whether you want to do it this way or not, is I can make the columns a little bit narrower, okay, like so, and then I just, make it wrap, right? Just make it wrap around. So I can go to here, turn on wrapping, like so. So is that okay, or do you guys prefer the really wide format? This is okay? Wrapping around is okay? Okay, all right. So we'll do the wrapping around. So we'll do the same thing over here. Wrapping. There we go. And now we can make it a little bit narrower just so that we don't lose track of stuff. Okay, good point. All right, so where are we now? Okay, we have just set up column H and column I. So that means we're ready to go to the beginning of the function that we're calling. What function are we calling? There's only one function that we're calling here, right? Function f. Yep. So we go to function f or the beginning of function f, which is on line 7. But this time when we, oops, I typed the wrong thing. But this time when we get to line 8, n equals to 0 or n equals 1 is actually true. So that means, oh, okay, we don't have to go for the recursive call anymore. We can now say that, oh, we are just returning the value of n this time. So that particular n is the one that is in column I. Okay, so that means we are executing return 1. Okay, we're executing the return statement with a value of 1 because the entire right-hand side of the return statement is really just 1. So let me just pause, okay, and make sure that we understand why we are returning a value of 1 at this time. Are we good or not? Or do you guys need more time to figure this out? So we're good. We got some people saying it's good. I don't see anyone. Yep, go ahead, please. We're gonna get back to it later. Yep, it is. So this part here, okay, let me use a mouse pointer so people who are missing the lecture can see what I'm pointing at. So this is what is left to do when we get back to line 8. So the entire thing, other than the question mark, is what we still have to do on line 8. Yep, when we get back to it. Okay, so we are now executing return 1. So how do we execute a return statement? We locate the rightmost column that is labeled return info. So in this case, it is column H. Okay, and then so we go here and then we copy and paste whatever value is in that column. And then what do? We replace the question mark with the value that we are returning, which in this case is 1, right? So now we go here and then we just replace that question mark with a 1. That's all we do. And then we do that one extra thing of copying this over here, okay? Because we need to know when we get back to line 8, this is what is left for us to do. And I'm going to do the wraparound thing over here as well so that we don't kind of make everything too wide. So we do the wrapping and then just wrap it around like so. And then after that, we have no use of both of these columns. Okay, so every column that you allocate for one particular function invocation, they need to go at the same time. Okay, they need to be deallocated at the same time. So Alt Shift 5 is how you strike it out, like so. And now we're back to line 8. Okay, so the confusing part is we just went from line 8 back to line 8. Is that right? The answer is yes, we did. Okay, but what is different is on row 14, the context of line 8 is different from the context of row 16. On row 14, the context of executing line 8 is using column I as n. When we get back to line 16, the context of line 8 is no longer using column I for n, it is now using column G for n. That is the main difference. Okay, so even though it looks like quote unquote a loop, or we are unwinding a loop, okay, it is not really a loop, because every time we get back to line 8 in this context, we are changing the context. We're changing, oh, but wait, which column is providing the value of n? That is changing. Is that all right? Okay, so that is really kind of important to note. Okay, so if you're not taking notes, I'm guessing you have exceptionally good memory, or you're counting on watching the video again, because unless you have taken this class before, which I have no idea why you're here, these are not easy concepts to grasp, which also means it is essential that you either watch the video again. I know, this is a tool. I give you this tool. I give you the resource. Use it. But if you're not planning to watch the video again, then writing down the notes is really important. Okay. All right, so we are now back to line 8, but line 8 now looks like this, which means the first call of f is already resolved. We just have to find out, okay, are we ready to execute a return statement? The answer is, no, we're not ready, because we have to figure out what is the return value of f of n minus 2. So we have to call again, okay? So we have to call f again, but this time we are using n minus 2 as the argument. So now we have to set up, the return info cell again. So the way we set up the return info cell is we allocate the leftmost available column. This column is now available again because we just deallocated it. This column, not yet. Okay, it is still occupied. So this column we can allocate again. So we're going to reallocate this column to be our new return info column. And in this one, we have to remember, oh, by the way, we're just getting back to line 8, and this is what is left of line 8. So we repeat the whole thing. Okay, return n equals to 0 or n equals 1, question mark, and colon, 1 plus question mark. Okay, because the entire invocation of f of n minus 2 is now replaced by the question mark, which is the placeholder for the return value of the invocation of f of n minus 2. So this is how we denote the return info. And now we also have to indicate what about the argument. In other words, n minus 2, what does it evaluate to? Well, this is the n that we are setting up in column I, so we cannot use the value of column I to calculate n minus 2. The only column, or the rightmost column that is labeled n that has a value is column G again. It is a 2. 2 minus 2 is a 0. So we put a 0 here. So now we are ready to kind of get back to the beginning of function f again, because this is a function call. So function f goes like, okay, we start with line 7, which doesn't do a single thing. We get back on line 8, we evaluate the condition, n equals to 0 is true. Okay, we don't even bother to evaluate n equals to 1. Why? Because, okay, what is the name of that mechanism of evaluating only one of the two sides if one side is giving us enough information for a conclusion? Short circuit evaluation, very good. So we talked about that on Monday as well. Okay, this is called the short circuit evaluation. So now we say, oh, okay, we know it's true, so that means we are ready to return. So if it is true, we are returning the middle or the second item in a ternary expression, which is n in this case. So that means, oh, n is a 0, so we are returning a value of 0. So we are executing the return statement, which means locate the rightmost column that is labeled return info, okay, which is this one, copy and paste it, look up where the question mark is. There should only be one single question mark, okay? If you have two question marks or no question marks, then something is not right, okay? There should only be one single question mark, and then we replace that question mark with the value that we are returning, which is 0 in this case, and that resolves the question mark. And then we do the usual thing, which is skipping one row, copy the return info cell over here. The reason why we skip one row is because I need another row to indicate that the columns are now deallocated. That is the reason. Okay. So now the execution of the program gets back to line 8. So you can see that we are basically going to line 8 a whole lot of times, okay? So, but this time when we get back to line 8, we go like, can we actually execute the return statement itself? Do we know what value we're supposed to return? The answer is, yeah, we do. Okay. Because at this point, what is this n referring to? This n is referring to always the rightmost column that is labeled n. It's not column I because column I is already gone. So that means the rightmost column that is labeled n is column G, which has a value of 2. So that means, oh, okay, so we have to return 1 plus 0 in this case because of the behavior of a ternary operator. So that means, oh, okay, fine. We can execute return 1 now. Are we good? All right. So what do we do when we execute a return statement with a value of 1? Yep. Locate the rightmost column that is labeled return info, okay, which in this case is column F. Copy and paste it. Change the question mark to the value that we are returning. And this one, it does have two question marks. That's because the first question mark is part of the ternary expression. So I do apologize for choosing the question mark as a placeholder, but at the time it seemed like a good idea. I did not use C++ as the language for this class until last semester. I have always been using like some kind of a pseudocode where question mark is not used as an operator, but in C++ it is. So is this particular question mark that we have to replace with a value of 1 because we're returning a value of 1 in this case. So that's all we do, okay, on line 8. So this one looks awfully confusing, right? Because column B looks almost the same thing as column F. What is going on here? So what is going on here is column B tells us what statement we are actually executing. Column F is telling us the effect of executing the return statement in column B. Let me say that one more time, okay? I know you guys are not taking notes, but you might want to kind of jot down the time because I think this statement is super important in this entire trace because this is the first time that we see something like this. Column B and column F look almost the same. Okay, not exactly the same, but really close. Okay, so what is going on here? Column B is the instruction that we are following. We are doing what column B is specifying. Column F is the result of executing the statement in column B. They just so happen to look very similar. Are we good with that? Okay. All right. So now we are pretty much done. Okay. So we do the other thing, which is copy whatever is in column F over here, and then we basically now we can say, oh, okay, those columns are no longer in use. I'm doing the lazier thing, which is copy and pasting the structural version. All right. So we are back to line 8 again. So this time when we got back to line 8, um, let's see. Yeah, we're good. We're good here. Okay, so this time when we get back to line 8, we go like, okay, can we actually do the return at this point? The answer is no, because we still have one more function call to deal with here. So we go like, not again. Well, trust me, this is not going to be very painful. This one is easy because this n is referring to the n that is the rightmost column that is labeled n. This n is gone. This n is gone. We only have this n left, which is a 3. Okay, so now we go like, oh, okay, so this n is referring to the 3, so that means we have to set up a function call where the argument to function f is 3 minus 2, which is a 1. Okay, we can do that. We now have to allocate the leftmost available column, which is column f at this point, label it return info because that's what we're going to use it for, and then we have to copy and paste basically this entire cell over here, but replace the question. Uh, nope, that is not what I want. I actually just want to copy the value. There we go. All right. So now they look exactly the same, but we have to remember it is the function call that needs to be replaced with a question mark. So now we take this out, replace it with a question mark, and then we set up the next column or the leftmost available column again, label n, and this time it has a value of 1. And then we are done setting up the two columns, and we are now ready to begin the execution at the beginning of the called function. The called function is f in this case. So now we go back to line 7. Line 7 doesn't do a single thing. We go to line 8. Line 8 says, does n equal to 0? No. Or does n equal to 1? Yes. So the whole expression is true, which means we are now ready to execute um, we are now ready, we now know what the return value is because it is just n itself, which is 1. So we are now executing return 1. And when we execute the return statement, we look up the the rightmost column that is labeled return info, which is this one this time, copy and paste it, replace the question mark with the value that we're actually returning, like so, and then we are done. So now we skip one row, copy and paste the return info cell that has the question mark already replaced. And then now we can say these two rows, or these two columns are now deallocated. So I'm just going to copy and paste the struck out version. So now we are getting back to line 8 again. Okay. And this time we go like, can we execute the return statement now? Do we know what value we are returning? And the answer is yes, we do. Okay, there are no function calls left in this particular return or line 8. So we go like, okay, we're supposed to return a value of 2, which means this entire thing boils down to return 2. So what do we do when we execute a return statement? The same boring stuff again, right? Look up the rightmost column that is labeled return info, and there's only one left, which is column D. Okay, copy and paste it, and then replace the question mark with the return value, which is 2 this time. Okay, done. And now we skip a row, okay, and remind ourselves when we get back to line 13, this is what is left of line 13 to do. And then we do the same thing, deallocate the two columns, return info and n. They both need to be deallocated at this point. So now we are back to line 13. Are we ready to perform the assignment operation? Okay, so we know the right-hand side is a 2. The left-hand side specifies x. We have to look up where x is, which is the rightmost column that is labeled x. There's only one column labeled x anyway, which is column C. So column C is the one that is updated to a value of 2. Then we proceed to line 14, and we're done. All right. Any questions about any part of this trace? Sure, absolutely. So let me put, um, yeah, go ahead. Okay, I can maximize the screen so this way we can show more rows. Any questions? So this is in the shared folder. This entire Google Sheets is in the shared folder. So which also means you can make a copy. Okay, so you can go to File, and then you can go to make a copy. So this way you have your own copy, which also means if you want to take notes, you can actually right click on the cell, go to insert note, okay? And then you can say, this specifies what we are doing, okay, which is what I said earlier. And then right click on this one, go to insert note again, and then specify that this is the effect of executing the statement in column B. So that's one way for you to take notes. If that is how you want to do it, you can obviously do it in many other ways. But the point is, you can make a copy of the entire Google Sheets and then use it to take notes, print it out, put stickies on it, do whatever you want. Okay, you can color code things if you want to, because it is yours. And you can use it also in your next exam. In exam two, which is also open book and open notes, it's the same thing. Bring anything that is on paper. You can bring anything that is on paper, which includes all the programs that we worked on during the lectures. You can take all of those with you in case you go like, okay, I might need a reminder of what to do in this kind of situation. You can then look it up. All right. Any questions? Because I know this is not easy, not an easy class. In a way, it is super easy because once you understand the mechanism, I know some of you were already thinking, ah, it's the same thing. Look at the rightmost column labeled return info, blah, 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 blah. Because it really is the same mechanism that we have repeated. I don't even remember how many times. Okay. But the key is to understand the mechanism itself. The spreadsheet is only here to help you visualize the mechanism. Without the spreadsheet, it's really kind of hard to track all of these things. But with the spreadsheet, everything is trackable. You just look up things and go like, oh, right, this is what is left on that line that I need to do. Because without that, I cannot remember which stage is, um, let me try to rephrase it. Without the spreadsheet, I would not be able to track what is the stage on a particular line, how much of that line is already done. All right. So are we doing okay? Do you guys need more time to look at this and talk about it? Yeah, go ahead. Uh-huh. Yeah, scroll up. Okay. So one thing you guys can do is you can go to the same spreadsheet and then put the cursor on the cell that you want me to look at. Then I can actually just follow your cursor too. Okay, go ahead. Which row? Row 8 and 9, these two. All right. Okay, so do you want me to explain it? Okay, cool. So the best part about a trace like this is you can point to any row and I can tell the context right away because the entire context, the entire state of the program is in the trace. So that means if you point to row 8, which is logging, what do we do on line 8 the first time? Okay. How do we know it's the first time? Because line 8 looks just like 8. It doesn't have 8 colon blah, blah, blah. So it's the first time. So the first time we get to line 8, the very first thing we need to do is to evaluate the first part of the ternary expression. And that's what we did over here. So after we evaluate the first part of the ternary expression, we decide that because it is a false, we now have to evaluate the third part of the ternary expression. But the third part of the ternary expression is not a constant. It is the sum of two function calls to f. So that means I have to handle the function calls one at a time. So that means I want to handle the left one first, which is what this question mark is indicating, is I'm handling the left-hand side of the addition first. But to handle that part, I also need to know what argument I should use to pass to parameter n of this new function call to f. So that means I have to evaluate n minus 1. At that particular point of time, the only column that is already set up that is labeled n is column E, which had a value of 3. So I'm looking at 3 minus 1, which is a 2, and that's why that's a 2 over here. Is that okay? Oh, I didn't actually address the question. Go ahead. You mean why this question mark is here and not two? Hmm. We never figure out it is a two until the last portion here. This is the only time we figure out that f of 3 is a 2. That's the first time. This is the first time because, oh, sorry, somebody has a question. Hmm. Oh, you mean why we have a question mark here, and then we have the question mark over here, column H, this one? Yes, because they're different invocations. Well, we have not found out anything yet at this point, because at this point, this one is still open. This question mark is still open. We still don't know what goes into that question mark. But the context is different because when we wrote this down in F9, the context for that particular thing is we are using column E as this n over here. But when we are looking at this particular cell, the context is using column G when we try to evaluate this. So they are two different contexts. It's almost like two people reading the same on the same page of an instruction manual, but each one is at a different stage of doing something. So it's kind of like one person get to a certain point. It's like, okay, I need the answer to this question, but I'm not going to do it. I'm going to ask you to do it. So the first person has paused and go like, I'm going to wait until you give me the answer so that I can continue to do what I'm supposed to do. So now you, as the second person, which is the second invocation, is going like, okay, I need to figure out what I'm supposed to do. It just turns out that you two are both following the same manual, but the original problem that were given to both of you to solve are slightly different. So in your case, you are asked to solve a problem with n equals 2. But in your case, you are asked to solve the problem when n equals to 1. So that's why you have a different problem to solve, and you come to the same a conclusion. So you return your answer back to the first person and go like, okay, the question that you asked me, this is the answer, so that you can continue with whatever you need to do. It just turns out that both of you are following the same instructions. So the function definition, which is what we see over here, that's just the instruction. The columns are representing a person. So that means this is the context of the first person. This is the context of the second person. This is the context of the third person. They are all following the same instruction manual, but there are three of them, and each one is operating from his or her own little post-it note or whatever that will help that person keep track of the context of the execution. Is that okay? Hmm. So then it will keep continuing. Yes. Then you have an endless recursion, which is usually not a good thing. Yes. Yes. So what you're saying is this particular return statement, if this condition is always false, then it will always go for some kind of recursive call, which means, in this analogy, we're going to run out of columns. But in the case of a computer, it will run out of what we call stack space. So that concept I don't want to bring into this class because it's a little bit forward. When you get to CISP 310, which is assembly language programming, it's called computer organization now. So if you take that class from me, then it's almost like a resume of this entire discussion, but in the context of actual memory locations inside a computer. So the way I describe things in this class is already setting you up for additional classes that you have to take in the track of computer science. Mhm. All right. So any other questions about this? We only got about 5 minutes left, so I don't want to start on the third one or anything else. Um, but there are three versions. Okay, so just taking a step back. Okay, there are three programs like this. They are in increasing order of difficulty to track. The first one is where's my mouse pad? Oh, I think it's the last one. Okay, the first one is nope, that's not the one. It's this one actually. Okay, so the first one is the easiest to follow. Okay, this is the easiest one to follow. It has exactly the same logic, but everything is like super spelled out. Okay, there's no executing a return statement to change a return info cell of another return statement. So this one is really easy to understand. Okay, even though it is also recursive. And then the next one, which is this one over here, is a little bit harder to track, okay? But it is still a little bit easier to track because instead of using a ternary expression, I'm using a full conditional statement, okay? So it's easier to track because the returning end is here, returning the other one is over here, so they're on different lines. The third one of exactly the same logic is the one that we just tracked today using the ternary expression. So they are in increasing difficulty in terms of reading, but in terms of the line numbers or number of lines, this one is the longest, okay? Because we are using a unnecessary local variable r so that I can break up all the operations on different lines. This one is a little bit, more concise because I'm not using a temporary variable called r anymore. So that means it's a little bit more cryptic. This one is the most cryptic because this one is combining the conditional statement into a single ternary expression. So that makes this one the most cryptic version. But once again, in this class, I will not be asking you to write anything. So you don't have to be worrying about, okay, I'm not really sure I can come up with something like that. That is not the point of this class, at least not from my perspective. What I do want you to do is to be able to follow the instructions because that's how I want you guys to do things. Okay, you have to understand the mechanism and be able to demonstrate that you understand the mechanism. So one more thing before I let you guys go, which may be helpful to some people, may not, okay, but it might be helpful to some people, is for this homework, okay, for the homework that is due next Wednesday, this program actually compiles and runs. So you can actually put this in online GDB and watch it run. Okay. Now, how whether it's helpful to watch it run or not, okay, is kind of up to you. Okay, but at least you will know what the result is supposed to be. Okay, so that means you can, in a way, verify your own trace. Okay, as a result. But it does run. Okay, I tried it already. It did what I thought it should be doing. So that's just one extra tool to help you out, when you are doing the homework assignment. All right. So that's it for today. I will see all of you on next Wednesday for sure. But on Monday, once again, I will have the optional lecture. If you are on campus and can come to class, I highly recommend being here. But if you cannot, or for whatever reason you don't want to come to the Monday optional lecture, at least watch the video. Okay, I cannot overemphasize why that is super duper important. All right, so I'm gonna stop the lecture now and stop the recording, and I'll see all of you next Monday or Wednesday. Have a nice weekend.